Evaluating logs depends on this single formula, which is really important. Whatever log base it has, if you have a to some power, then these two, the log a and this a, they cancel, and it leaves you with this x. So it's a very important thing. So let me first show you how you can use that to find log base 3 of 1 over 27. Well, your goal is to make this one number, 1 over 27, into 3 to some power, because if you want to have log 3 of 3 to the x, then we can cancel and then you have the answer, right? So you first think about 27 and realize that 27 is 3 to the third power, right? Because if you do 3 times 3 times 3, that's 27. And then you also know that if you have 1 over, that's 3 to the negative 3 power, right? And then 3 and log 3, they cancel. And that gives you negative 3. Now, log 2 of 2 to the first power, 2 to the 1/2 power. This is log 2, 1 plus 1/2, that's 3 over 2, right? And then log 2 and 2, they cancel. And therefore, you end up with 3 over 2. Here, 49, just think about what it would be with respect to 7. So because this is log base 7, your goal is to make everything a 7 to some power, okay? 49 is 7 squared. And cube root of 7 is 1/3 power. So that might be something that you forgot. The nth root of any number is a to 1 over nth power. And also square root of a would be a to the 1/2 power. That's something you must remember. So we have this. And then when you have division with the same base, these two numbers subtract. So you end up with log base 7. 7 to the 2 minus 1/3. Well, let's see. 2 is 6 over 3 is 2, right? And if you do 1/3, if you subtract 1/3, 6 minus 1 is 5. So that gives you 5 over 3. And because of this, this is log base 7 of 5 over 3. And again, there's a cancellation between the log and the exponential function, and you end up with 5 over 3. And it's pretty much the same thing, except now you have to remember that if you don't have a base, that means it's a log with base 10. Okay, and then you have 10 to the, well, fifth root, we remember it's 1/5 power, right? We just mentioned that rule. Okay, again, log with nothing under it, that means log with base 10. And fifth root is same as 10 to the 1/5 power. And then whenever you have two things like that, then these two multiply. One thing is that it is kind of tempting to cancel log 10 with 10 at this point, but you can't, because this has like some complex structure. Only if you have a very simple form of log of some number and the same number here, and then you have some exponent, these two may cancel, okay? So you're not allowed to cancel it yet. You can after 1/5 times 7 is multiplied. You just have to have it exactly in this form in order for the cancellation rule to work. And therefore you end up with 7 over 5. Now, sometimes it's not so easy to see what this number would be in terms of powers of 8. I have no idea what 8 to what power would 32 equal to. And this is probably the most challenging one from A through F. So let me show you several approaches and see which one you like the best. Okay, so approach 1 would be actually doing this. Just put an X here. So think about this question. I need to write 32 as 8 to some power, okay? And I don't know what that is, so I'm going to put it as X. Okay, then I see that both 32 and 8 are powers of 2. So I can rewrite 32 as, let's see, 2 times 2 is 4, 2 times 2 times 2 is 8, 2 times 2 times 2 times 2 is 16, and then 2 to the 5th power would be 32, okay? So if you multiply 2 by itself 5 times, then you get 32, whereas 8 is 2 to the 3rd power. And then you know that these two multiply. If you have a parenthesis with two exponents like that, they multiply. That's exactly what we did here, right? So you have 2 to the 3x. And therefore, these two exponents should match. Since the bottoms match, 2 and 2 match, for these two to be equal, 5 must be equal to 3x. Which means if you divide both sides by 3, you end up with x equals to 5 over 3. Okay, so this is what we just figured out. We found that log 8 of 32 can be written as log 8. 32 is 8 to the 5 over 3 power, and therefore now you can cancel, and that's equal to 5 over 3. Okay, now let me show you another method. So that will be method 1. Method 2, what you want to do is you can use something called the base change formula. So what is the base change formula? It says if you have log 8 of 32, you can rewrite this as log of 32 over log of 8. And here, log without any base means log base 10, okay? Or you can also use ln of 32 over ln of 8. So either way is fine, and actually you can use any base. So this is log with base 10, this is log with base e, but you could also use log with base 2. And we can just use this to figure this out, because log 2 of 32, what's that? That's we just know that 32 is 2 to the 5th power, right? And then log 2 of 8, 8 is 2 to the 3rd power. So after doing the cancellation, then you end up with just 5 over 3. So that's quicker if you know what this base change formula is. Now, still another method is if you think you have hard time thinking about choosing log base 2, then you can just use either one of these. So let me show you. Log base 8 of 32 is same thing as log of 32 divided by log of 8. And log of 32 is log of 2 to the 5th power. And log of 8 is log of 2 to the 3rd power. And then we have this wonderful formula called jumping the frog over the log, right? So you can jump this number over the log and make it go front. Make it jump over the log. And the result is that you end up with 5 times log of 2 over 3 times log of 2. Log of 2 cancels, and you end up with 5 over 3. So that's yet another way to solve it. This f, it's actually a very easy problem. Let's see, 1 over 10 is 0.1, 1 over 100 is 0.01, and let's see, 1 over 1,000 is 0.001, how many do I have? Oh, I have 3. So 1 over 10,000 is 0.0001. Right? This is 1 over 10,000. And remember, this is log base 10, so it's log base 10 of 1 over 10,000. 10,000 is 10 to what power? This is 10, 10 squared, 10 to the 3rd power, 10 to the 4th power is 10,000. And right now, it's really really enticing to cancel these two, but you can't. You cannot cancel log 10 with this 10 because it's 1 over 10 over 4. Only if it's exactly in this format, log 10 of 10 to some power, then you're allowed to cancel these two. Alright, but we know that reciprocal is negative power, so it's log 10 base 10 of 10 to the negative 4, and these two cancel, and you end up with negative 4. So F was actually a pretty easy question if you knew it. Solve these equations, give both simplified exact solution and also the approximation to 4 decimal places. Alright, I guess the hard part will be approximating to 4 decimal places. Okay, so for that, I'm going to use my scientific calculator here. Alright, but I'll use it when I need it. First, the easy part is what's 3 to the x equals to 4? What's the value of x? Well, solving equations, it all has to do with the cancellation laws. Cancellation law is everything for logarithms. So you just apply log 3 both sides. And these two things cancel. And then that's the answer. The answer is x equals to log base 3 of 4. So that's the answer. That's the simplified exact solution. This is simplified exact solution. But what is that really in terms of decimals? Well, let's bring our calculator. Now, so this, I'm just using calculator.net, but you'll be using some scientific calculator for that. So let's see. I need log base 3 of 4. That's what I need. But unfortunately, most calculators do not have log with any base. It only has 2 types of logs, which is log with base e here or log with base 10. So how do you use this calculator to calculate log 3 of 4? That's why the base change formula is so important. The base change formula says, let me write it here, base change formula allows us to compute log with any base like 3 here, even if the calculator does not have log with base 3. It says this is the same as log base 10 of 4 divided by log base 3. So all you have to do is to calculate log of 4 and then divide by log of 3. Oh, it says 1.2618. Well, since we need 4 decimal places, the 8 would be rounded up to 2. So the number would be 1.262 if you round to the nearest thousands. 1.262. So that's the answer here, 1.262. Okay, what about this one? Well, here, in order to find x, you have to get rid of the log. To get rid of the log, you exponentiate both sides. So what you have to do is x to log x to the 5th power equals to x to the 7th power. And if you do that, there's another cancellation this way. So there are 2 types of cancellation. You have log applied to exponential function, and here's an exponential function, and the exponent is a log. in those cases. These are the two cases that they cancel. Alright, so you have 5 equals to x to the 7th power. To get rid of this 7th power, you can take the 7th root both sides. So you take the 7th root both sides, and that cancels the 7's, and you end up with x equals to 7th root of 5. So that is the exact answer. Exact. What's the approximation to 4 decimal places? Well, you have to use this. Again, in the calculator, if you look at the calculator, it has x cubed, x squared, but it doesn't have like arbitrary, well, it has this one, y, 7th root x. But you know what? I usually don't like this. I just want x to the y power. For me, that's the easiest one. So to use that, this is what I do. I say x is equal to 7th root of 5. That's same thing as 5 to the 1 over 7th power. Okay. And then you have the calculator. You have to calculate this. So let's use the calculator. 5 to x to the y means 5 to the power of parenthesis and 1/7, right? 1 divided by 7 parenthesis equals. Okay, so that's 1.25849. But if you round it, it's 1.258. That's the nearest four decimal. Okay, so let's x equals to 1. I forgot the number. 1.258. Okay, so rest of them are pretty similar, I would say. And then at some point we'll need to use all the log rules. We haven't gotten to using much log rules then, except the base change formula and frog over the log. But pretty soon we'll be using others. Alright, so you have log base 6 equals to 1/8. To get rid of this log 6, you raise both sides by the power of 6, and then these two cancel, and you end up with x equals to 6 to the 1/8 power. So this is fine as an answer. If you want, you can rewrite this as 8th root of 6. Either one will be given full credit. Now, again, to find the approximate value, I would be using the calculator and say 6 to the power, parenthesis, 1 divided by 8 equals 1.251. Next, here we have an equation like this, and you have to be careful because log of x squared can mean you have to decide what this means. Does this mean log of x squared and then you put a parenthesis, or does it mean log of x and then the entire thing is squared? Now in this case, if you don't have a parenthesis like this is the default mode. So we're gonna not accept this, and this should be felt as log with x squared. Okay? Now the reason I talk about this is because for this case, in this case only, we have the frog over the log rule. If you have log of x and then squared, this number may not jump over. That's not allowed. That's not the frog over the log. The frog over the log, frog has only two spots, either in front of the log or it's hiding inside the log. Okay? You can only hide inside the log, and then it will jump over and then come out over here. You can't have it above the log. That's not allowed. Alright, so this is same thing as 2 times log x by the frog over the log rule. And then 2 log x is equal to log of x plus 2. Subtract log x both sides. So that, see, don't be scared to subtract log of x. It's just some variable. So think about this log x as like a one thing, one object. So you have 2 times 2 logs and you have 1 log subtracted. These are the same kind of logs, so you can actually compute them. So you end up with just one single log on the left side equals to 2. Now, you have to remember that this is log base 10. If you have log without anything in the bottom, that means log base 10. And you're trying to get rid of the log 10 to figure out what x is. So what you need to do is you have to take power with respect to 10. So raise both sides over 10. So that 10 to the log 10 of x, well, we know that these two cancel. And therefore you get x on the left side. On the other side, 10 squared, well, that's 100. So x equal to 100 is an exact answer, and this is also a numerical answer, so there's no need to use calculator for this. Solved equations give both simplified. It's the same thing, so let's continue on. Here, ln of x squared equals to 9. Well, how do you get rid of the square? You take the square root both sides, but whenever you take square root, be careful, you need plus or minus square root. And square root of 9 is 3, so you have plus or minus 3. And then, what is ln? That's ln with base e. E is what we call natural number, or Euler number. Its value is like 2.7 something. So e is a 2.7 something value. Actually, this turns out to be pretty important in finance. Okay, and then this is either 3 or negative 3, right? So to get rid of this log e, what do? You say e to the log e of x is the same thing as e to the 3 or e to the negative 3. And the reason you do that is because e to log e, they cancel, and it brings down this x, and therefore you end up with x equals to e to the 3 or e to the negative 3. Okay, now I still need to figure out its decimal value, so let's use the calculator. And here it has e to the x, and that's very convenient because I don't have to type e. E to the power of 3 is 20.0855. So 2008 is 4 significant figures, and 55 that goes that rounds up. So 20.09 will be e to the 3. So you have x equals to 20.09. On the other hand, if you have e to the negative 3, let's see what that gives us. E to the negative 3. That's 0.049787, so rounds to 4979. So 0.04979. Okay, so these are the numeric answers with 4 significant figures. Okay, F, well, this is the x that we need to figure out. And here's the x, so I have to isolate x. So 1 has to go to subtract 1 both sides. 9 minus 1 is 8. And then you need 4 to go, so divide 4 both sides. So that gives you e to the negative 2x equals to 2. How do you get rid of e? You take ln both sides, because ln is the log base e. I apply ln both sides. And then ln and e cancels. And you end up with negative 2x equals to ln of 2. And finally, divide both sides by negative 2. and that gives you x equals to negative 1/2 ln of 2. Okay, that is the exact answer. To get the approximate value, you have to figure out ln of 2 and divide by 2 and put a minus sign. So let's do that. Ln of 2, and then divide this by 2, and you get 0.3466. So that's 0.3466. Okay, we have quite a lot of questions in 10. Oh, okay, up to 11. Alright, so let's try that much. Okay, for this one, you have 1/9, 9 and 3. Well, 9 is 3 squared, right? So we're going to write 1/3 squared x minus 2 equals to 3 to the x plus 1. And 1/, means that's the negative power. And then this number gets multiplied to negative 2, so you get 3 to the negative 2x plus 4 equals to 3 to the x plus 1. And then you have negative 2x plus 4 equals to x plus 1. And the reason for that is since the base are the same thing, for these two sides to be equal, their exponents must be the same. Or else how can they be equal, right? So you have this, and then I would add 2x both sides, and then subtract 1 both sides, so that this one's gone. X plus 2x is 3x. That's what you get on the right side. On the left side, 4 minus 1 is 3. Oh, so you just get 3. No, dividing by 3, you just get x equal to 1. And that's both an exact answer and a numerical answer, so we don't do anything more than that. That's the answer. Alright, now serious business. Minus between logs. What's the rule? Well, if you have log a of x and another log a of y, and you subtract, that becomes log a of x divided by y. So subtraction becomes division. Alright, so subtraction becomes division, so you have log base 2 x minus 1 divided by x minus 4 equals to 5. Now, you want to get rid of this log 2. What do? To get rid of log, you exponentiate both sides. You put it over as an exponent. And they cancel. And we have x minus 1 over x minus 4 equals to 2 to the 5th power is 32. Right? Okay, well, it's some equation. It looks horrible, but we can make it slightly better by multiplying by x minus 4. That way you don't have a fraction anymore, right? So I'm going to multiply x minus 4 both sides. X minus 4, 32. So x minus 4 is multiplied, and these two cancel, and so you get x minus 1 equals to 32x minus 4 times 32, that's 128. Alright, I'm going to add 128 both sides, and then subtract x both sides, so that you don't have x here. Negative 1 plus 128 is 127, and 32x minus x, that's 31x. Okay, so x must be 127 divided by 31. And I don't think they have any common factors, so that's what most you can do. And in order to get the approximate value, I'll use the calculator again. Right, so 127 divided by 31. Oh, I still have that log of 2. So 127 divided by 31. 4.097. 4.097. Okay, so this is about 4.097. Okay, what about addition? What's the rule for addition? Well, log a of x, log a of y. If you add them, that becomes a single log. You can put them together in a single log, and inside you will have a multiplication. So let's do that. Put them together, x times x minus 2, actually x minus 12, equals to 3. Oh, by the way, let me go back, because I forgot something. I forgot to say something. See, when you have these values, you have to make sure that you can still plug them in and get the answer with no problem, because sometimes when you try to plug in logarithms, they have a domain of positive numbers only. So if you try to plug in negative or 0 into logs, immediately you get an undefined value. So thankfully this is a little more than 4, so if you plug in here, that will be positive. And of course 4 minus 1, that's 3, so this will be positive. So in both cases, you're plugging inside the log of some positive number. So here, this is indeed the answer. That's not a problem. But the reason I'm saying this is because sometimes if you solve logarithmic equations like this, especially when you end up putting two things together or putting things as a fraction, sometimes you get these solutions which are not true solutions. You call these extraneous solutions. So you have to watch out for them. When you get your answer, you have to go back and see when you plug it into your log, it does not violate this principle that inside the log you cannot plug in 0 or negative. It always has to be positive. So immediately what this is saying is that if you put something less than 12, say we got some answer and that answer was say 1. That's okay for here, but 1 minus 12 is negative, right? That wouldn't be a solution. So, well, we'll keep solving, but at the end of the day, we will have to figure out if there's any solution that's actually not a solution. Alright, so we put 2 together into a single thing, and now we want to get rid of this log 4, and to do that, we raise it over 4. 4 to 3, and then these two cancel, and you get x times x minus 12 equals to 4 to the third power, that's 64. So you have x squared minus 12x minus 64 equals to 0. Let's see, well, you know, this is a little too large, so it's probably hard to factor, but I just realized that negative 16 times positive 4 will be this. Negative 16 plus positive 4 is negative 12. So you can factor that as x minus 16. X plus 4 equal to 0. And therefore, for that to work, either x minus 16 is 0 or x plus 4 is 0. Either the first one is 0 or the second one is 0, right? And this says x is 16. And this says x equals to negative 4. Okay, so you have two possible solutions, but this second one, that was what I was talking about. This is a no-no, because if you have x equals to negative 4, you plug it in here, you get log with a negative number. That's not allowed, so that's not a solution. On the other hand, this is okay, because 16 minus 12, that's positive. 16 itself is a positive, so there's no problem with it. So the answer is x equal to 16 only. That's the only answer. Okay, another one of these addition becoming multiplication. ln will be x times 2. And how do you get rid of ln? Remember, ln is log base e. I'm going to write x times 2 as 2x. That's easier. And therefore, you want to raise it over e. The right side should be done the same. And then, now we have cancellation. We have 2 times x equals to e to the 3. So x must be 1/2 times e to the 3. So that's your exact solution. To get an approximate solution, it will be e to the 3 power. We already did that before, right? But you have to divide that by 2. So that will be 10.04. So approximately this will be 10.04. Okay, 2 more questions to go in number 10. So you have 9 is 3 squared, x minus 1, times 3 to the x equals to 27 is 3 cubed, right? So we write this, and then if you have 2 exponents like that, they multiply. So you have 3 to the twice of x, and then twice of negative 1 is negative 2, times 3 to the x equals to 3 to the 3rd power. And then you have the same base, so the exponents add up. So you have 3 to the 2x plus x, that's 3x, minus 2 equals to 3 cubed. And again, the same base, therefore the exponents has to match. So 3x minus 2 is 3, add 2 both sides, 3x is 5, divided by 3, so it's 5 over 3, and that's about 1.667. Okay, here we have log 2 applied twice. We just have to get rid of this log and then this log, and you're done, right? So how do you get rid of logs? You exponentiate. So 2 to this power is equal to 2 to square, and these 2 cancel. 2 squared is 4. This is brought down, so log 2 of x is equal to 4. Again, do the same thing, raise it over 2. 2 to the log 2 of x is 2 to the 4. 2 is brought, 2 cancels with the log 2. X is what you have, 2 to the 4th is 16, and done.